is what friends, if you are considering a the terminology of the model, it is nothing but your data and whatever the pre-processing technique you have applied along with the algorithm. Okay, there is a specification related to the model. So once you build the model, you can predict and you can come up with the metrics. Okay, these things we have observed. And few members were asked to explain the metrics of regression and classification. Today again you are going to get the revision of that. And now if you are referencing the distinction between supervised versus unsupervised. So there is a label, there is some sort of outcome. Uh, so here just we are having the clear-cut outcome related to the supervised learning. But whereas in case of unsupervised learning, our interest is not to generate a value, but rather we can see the patterns or some kind of the knowledge base. So from that particular thing, we are going to generate the knowledge base. And if you are talking about the supervised, we are having the classification and regression. These are the examples. Whereas if I'm talking about the unsupervised learning, I'm having the concept of clustering, principal component analysis, and association rule mining. All these things are belonging to the unsupervised aspects. Now let me introduce you. What do you mean by a clustering? Sometimes friends, you might be using the word clustering, group of similar items. Suppose cluster 1, cluster 2, cluster 3. Maybe I'm having the big data technologies here, cluster 1, and here I'm having the data science, which involves data science, data engineering, data analytics, everything. And in this big data, I'm having Hadoop ecosystem, processing of the huge data, Spark ecosystem, all these things as one cluster. This is another cluster. Cluster 3 is something like purely a development wing, maybe Python, Java, and SQL, all these things. So now the clusters gives us, this is one kind of the similarity. Okay, the elements within the cluster are having the similar properties. And if you consider the second cluster, it is also having some similar kind of the properties. And similarly, third one also. Now what we'll do is, guys, technically how I can make use of this particular cluster and in what way we are achieving the functionality of this clustering, because clustering is very much helpful whenever I need to get some relevant data and I want to perform some activities related to um, uh, combining the data sets and all these kind of the things. So in that case, just let us have a distinctions and all the advantages and applications of the clustering concept. I have compiled something for us, guys. So just have a look on this, which is from the literature. Okay. So what do you mean by clustering? It is a process of grouping similar entities together. Just now we have seen one example. The goal of the clustering is to find similarities in the data points and group similar data points together. And generally it is used for knowledge discovery rather than prediction. Observe, guys, here we are not going to predict anything. We are not going to generate any value, or we are not going to give any yes or no kind of the conventions. Rather, what we are doing is we are understanding the data. We are highlighting the knowledge from that particular similar kind of the items. and it provides an insight into the natural groupings found within the data. So whatever the existing parameters, whatever the existing options we are having from that particular groups, you can able to generate the insights of the data or patterns of the data, or you want to generate the knowledge, and discovering the knowledge is possible with respect to the clustering. Okay. Now, which are all the applications? Generally, guys, in the market analysis, like customer segmentation into groups with similar demographics or buying patterns for the targeted companies. And of course, if for Tesco or else Walmart, if they want to understand their customers, they need to track them and what they are buying and how much spendings they are doing and which are all the products they commonly take every month. All these kind of the things can be observed so that we can suggest them. You know, one thing in Tesco, just if you are purchasing some kind of the groceries, they suggest you like compared with this product, you can go with this kind of the product. Maybe some of the products may be having high sugar and high calories, like that. So what Tesco does is, okay, so though they are making, their intention is not to make the business, guys. Okay, better you go with rather than high calorie food and high sugar food or high protein. Protein is okay, but these kind of things which are causing harm to the customer's health, even though they are 5% or 5% to 10%, they are giving the reduction. Okay, maybe they are purchasing $10,000 per month, but maybe they are getting $9,500 also. They are suggesting some products which are better for the health of the customers. And at the same time, if they are losing $500 also, they are not minding. So that is a Tesco kind of thing. Like they are giving more importance to the customers. Business may not always, guys, always for not the money sake. Okay, some of the companies, you know, definitely they maybe their products are meant for the kids. Okay, so in that particular case, usage of the chemicals may cause trouble to their health. So in that particular case, definitely they need to suggest some better products if the customers are not aware. So definitely customers are not aware of all these scientific or chemical kind of the chemicals used in the products and all. They just to go by publicity or something like that. So, but these kind of the companies, you know, so just they are studying the customers and they are suggesting the better products. So, which is the key success factor. Okay, you can take up that case study also, guys. Tesco case study, where there is an app actually, and within that app also they are okay. Suppose if you are unable to find out such a bigger malls, and you are unable you are aware of that particular place, but you are unable to find out where that product is located. So through that particular app you can observe, okay, this particular product is available in this rack and so and so. It guides us actually. So all these kind of the things are possible with the observation of the customers. Whenever customers are facing some difficulty or customer needs some help from the app or any other, so just they are utilizing that particular opportunity. And another important point, guys, already we have discussed this point, like sometimes suppose maybe you are having some Facebook or Twitter or whichever the account, maybe you are having some friend list, and this app suggests some kind of the products also, because based on the way you communicate and how you are using your terminology and how your friendship is there, like that they are going to estimate some bonding between you and your friend. Accordingly, just it is going to suggest some kind of the products. See, these are all not rocket sciences, friends, definitely. So, because at the moment I'm thinking about the data science, machine learning, and all is a purely human related technology. So, just if I'm talking about the student number of hours preparation, whether he is going to get rank or not. And another important thing is like suppose World Bank is spending some amount. in the studies of the students, uh, and they are offered afternoon lunch also. And whether these guys, which we are offering for offering lunch, whether they are doing really good or not, whether male students are doing better than female, or what is the trend. And another important thing is, suppose if the parents are graduated, okay, if they are having UG degree or PG degree, if they are having education background, is there any impact on the students study or something? And another point is, they would have conducted some written test, and as well as the reading and writing test, whether this really influencing the final university examinations. See, all these kind of things are not from the external entities, guys. They are all our problems, and they are all our understandings, and how we are making use of the conventions. Okay. And friends, I'm requesting you. So just if you are also you would have faced these kind of the real time scenarios while you are going through a blog, or while preparing something, you can also free to post the same, guys, because these are all my experiences while teaching. Just I used to pick up the appropriate case studies, and all these case studies are absolutely like TV marketing, and as well as the radio and newspaper marketing, and whether that is impact on the sales or not. So the companies, that is a major problem. Okay, so definitely publicity should be there, but we have to publicize the things in a proper channel. Reachability is most important, so that automatically after reaching to the customers, definitely we are going to get some kind of the outcome. Uh, like that. Okay, so just we are making use of the conventions, and sometimes just they ask us the feedback about the product, and maybe by using, and even the marketing executives, salespersons may not have the idea, and even our strategic team may not have the idea, but customers, okay, customers are not thinking about the business and all the other strategies or market. They think about the product, and how that product is useful for their life, and whether they have it is having any impact, or it is reached to its expectation, and what has gone wrong. All these kind of the points can be taken, guys. So the observation here is, while talking about the data science or machine learning, you have that human nature, guys. Okay, maybe in terms of Python or Java implementations, you may have to have the skill set and all the things. But especially if you want to settle down as a data scientist or machine learning developer, then definitely you need to integrate your human touch with respect to the technology also. Okay, so because the way you think, that's what I said, the subject matter experts, statistical members, common sense reasoning is a mandatory along with the skill set. So how best you can think as a in the shoes of the customers, then definitely you can come up with a nice analogy and understanding of the data. And data storytelling interpretation is also important. I should have given some task related to that, guys. Okay, so let me see if I can give to Krishna related to data storytelling, or else I will scope that aspect also, guys. Data storytelling related to the data science. Let me see whether Apache is having any blog, or Databricks is having any blog, and where do we start, and how we are going to explore the things. Okay, definitely I'll scope that point. And detecting anomalous behavior such as unauthorized instructions into computer networks by identifying the patterns of use falling outside of the groups or cluster. And this generally happens, guys. I'll give you some other example. Maybe you are using the credit card, and generally you spend maximum 2 lakhs per month. Okay, assume that. Now that particular month, maybe your 2 lakh expenses reach to 5 lakh. Assume that maybe your credit card is having some 15 lakh or something gold member you are, and you are having that range of usage. Now there is around 3 lakh differentiation. Immediately, banks suspect that, and sometimes you may receive the call or mail or whichever. So because this is abnormal pattern, friends, from past 12 months, Okay, you are on average, you are spending 2 lakh only. But suddenly there is a bump in the corresponding spending. It reaches to 5 lakh. Okay, so bank suspects that definitely, and they reach you guys actually. So in terms of the mail, or maybe some executive may call you, and really it is your spending or what's happening like. So they suspects that because the pattern is not there, and now you are having another pattern or another kind of the spending. Okay. And some other time, so like you are in, you have used your cart, okay, in Bangalore, okay, just to have purchased some kind of the laptop or something, or 75K or like that. Now within 5 minutes, okay, from US also, okay, just to have purchased some kind of the wallet, okay, something like that. Maybe that wallet may be antivirus software or whichever. Now, see here, there is a logical disconnect between these two actually. Maybe you are in India, and maybe your brother may be in US. Maybe he would have, he is using that credit card along with you. Maybe he's having all the credentials, and online without, we cannot, we need not give credit card now while purchasing online. So just it is enough to enter that CVV and all these kind of the details, and OTP of course, from you he would have taken, he or she. So, but logically, friend, there is a disconnect. How come one person from India within 5 minutes from US, from the same credit card, how he is going to purchase? So these are all the real-time cases only, guys. And I am also strongly recommends you, just you while taking your problem statement. Okay, don't take rocket science or embedded systems or IoT or something like that. Of course, from the civil background or mechanical background, if you are having, you can take that also, guys. How much the sand and cement, how to mix up, and what percentage, because that is also one kind of the research actually. Okay, if those kind of the case studies are there according to your domain knowledge, definitely you can take and come up with the analogy. But my strong recommendation is focus on the generic problems. Okay, like market basket analysis, and the student, as I said, if World Bank is sponsoring, and whether what is the rate of success, okay, the literacy rate, how it is reflecting, and then some supermarket example I have given, Tesco kind of thing, or you go and pick up the things, guys, and it's not definitely that much difficult. Okay, only the thing is you need to coin the corresponding statement, and don't as it easily get the contents, guys, because though you are getting the code, it's fine, because code you are not going to uh, create now, of course. Okay, just you can change here and there, and that is fine. But only the thing is, just to pick up the data set, understand that, and what is the outcome, and how we are going to implement those kind of the aspects, that is major consideration. And why do we need clustering? And it is a technique generally used to initial profiling of the portfolio. Friends, here, um, assume that we are recruiting some 100 members. Okay, we need some 100 data engineers and 100 data scientists. Assume that. So first, the HR people, what they do is based on our requirement, maybe from various BUs, HR would have received some kind of the job description, and their task is to discuss with the subject matter expert or initial screening member, so that they can shortlist all the whatever the resumes or whatever the CVs they got. So this is what you call the initial profiling. It doesn't mean that whoever shortlisted, we are going to consider his candidature for the final interview. No. Okay, just they're all the keywords might be there related to our requirement, suitability. And then only after the first screening, then only we are going to shortlist, and actual process starts from there only. So after having a good understanding of the portfolio, an objective modeling technique is easy to build a specific strategy. Even it's not a strange thing, guys. Maybe if you are observing some kind of the case studies, sometimes first we need to apply the clustering, and after getting the sense of that particular data, one can easily apply the classification or regression kind of thing, so that to avoid unnecessary paths. because in the landscape of the data science, sometimes we may work with the huge amounts of the data, heavy data loads. So in that particular case, our dimensions cause some kind of the complexity, that there where we are using the concept of the dimensionality reduction. So these kind of portfolios, whatever the things I'm having, and first I need to segregate and shortlist all those aspects. I'm having a case study for us, guys. So before that, let me start the cluster. So before our discussion, and then we'll have a look on that. I have picked up some case study for us, which is of course again the market basket analysis related to the people. Uh, Let me create the cluster. Is trying to, where is, okay. So some mall customers data. Okay, I'm coming back to this thing. Okay. Now, which are all the types of the clustering friends? Maybe like multiple clustering techniques are there, but predominantly we use either hierarchical or k-means clustering. K-means is a most frequently used kind of the clustering friends. Okay, let us see one by one. So what exactly the k-means and how it is performing. And in terms of the hierarchical clustering friends, hierarchy you might be knowing, like from the database terminology, hierarchical just specifies that there is some kind of the department. I can say like manager and the subordinates. If you see the organization, just we are having some hierarchical representation. Okay, see here, just we are having the way in the hierarchical format. All these members are spread. So this technique operates on the simplest principle. A data point closer to the base point will behave more similar compared to a data point which is far from the base point. What we're saying here is, guys, maybe just I'm having the data science. This is the major base, and all the data scientist can be reflected here. And we are taking machine learning and all the members. Of course, from the data science, machine learning, of course, is a subset kind of thing where we are getting all the ML developers and all, and DE guys, where these guys are having knowledge on data pre-processing, loading of the data. Okay, all these kind of the conventions. So initial point, this technique operates on the simplest principle. A data point closer to the base point will behave more similar compared to a data point which is far from the base point. Now, if I am considering, like, guys, just if I am making use of this DE, and if you compare this guy may be doing additional tasks compared with this DE guy, because DE functionalities are limited, but data scientist functionalities are unlimited, guys. Already we have seen the data scientist is a combination of DE, machine learning, and domain knowledge must be there, and subject matter expertise. All these kind of the consideration should be taken from the should be the profile of the data scientist. Whereas DE and ML developers are having some sort of observations, and we're also not going to expect many things from them. Okay, because the profile is like. Now, if you are referencing hierarchical clustering, start with all the data points assigned to a cluster, it's one. Whatever the data points I am having, first we need to consider all data points. And each iteration, we compare each data cluster against the other, and then two nearest clusters are merged into the same cluster. So just we are having some kind of the points, and the nearest clusters can be combined into a common cluster. So like that, it is forming some set of the hierarchies. Now you see here, just we are starting with all the data points. Now we are merging the commonalities DE, and then we are merging DEF, and here also BC, all these kind of the mergers. And finally, so if you, though we are having common clusters, and I mean a particular cluster related to that cluster, we are having the similar points. And the this particular cluster, okay, which is having the notion of, okay, so these are all the distances. Okay, based on the distance calculation, we are going to find out the similarities among these particular data items. And obviously the cluster mechanism place the similar kind of the points into that cluster as a subset of the data items. Okay, and we continue this process, and this algorithm terminates when there is only one single cluster, because there should be some limitation, there should be some termination, otherwise it goes off into the infinite loop. So rather what you can do is just we can restrict our cluster. Okay, whenever I reach it to a single cluster, then we should stop the process. Our requirement is that only. And note the here the observations are the only problem with this technique that is able to handle only small number of the data points, and is very time consuming, friends, because every time the appropriate distance should be computed, and based on the threshold value it should push the corresponding point into the appropriate cluster, because it tries to calculate the distance between all the possible combinations and then take one decision to combine two groups or individual data points. Because the problem here is, guys, just we are making use of that distance calculation, then obviously it takes much time, and we have to wait until the corresponding thing. Okay, and moreover, the important point here is, guys, just if I am making use of this clustering and all, there is a main task actually, that is what you call the distance calculation. So if you are considering any algorithm, guys, no matter whether that is a clustering, classification, regression, each and every algorithm is having one important key point. So in terms of the clustering, that important key point is distance calculation. And how to calculate the distance? You are having Euclidean distance, Manhattan, Hamming, Jacob, okay, cosine, all these kind of the measures. Okay, all these kind of the measures are helping to form the clusters. Okay, is to form the clusters with distance computing. Okay, with the distance computing. So many things are there, friends. It is your wish. So like Euclidean and all these kind of thing. And this algorithm has been implemented using the bottom-up approach. Top to bottom means just we start here and we are going to work out here. It's not like that. So just it start like this, and it is going to explore bottom-up approach. And then it is also possible to follow top down, starting with all data points assigned in the same cluster, and recursively split till each data point is assigned to a separate cluster. So either top down or bottom up approach both works in the concept of the clustering. The decision of merging cluster is taken on the basis of the closeness of the cluster points. Obviously, now guys, just we are having some multiple points, and maybe 1, 2, 3, 4, these are all the points. 1 and 3 are having the similar distance, very near distance. So 1, 3 can be combined, and 2, 4 are having the similar kind of thing. Then 2, 4 can be combined. So like that, it is purely based on the distance calculation. One can easily refer the orientation of the clustering. So distance measure and all. Now I'm going to introduce you one more important technique called k-means clustering, friends, actually. So, and moreover, why this k-means clustering is so important is there is one more concept called elbow pattern. Maybe the data scientists who are in the call maybe would have worked on that particular elbow kind of the thing. So, but however, I'll talk about that particular elbow kind also. Now, observe here, guys. K means clustering, because in the hierarchy clustering, just we are dependent on the kind of the data and distance measures and all. Now here there is a clear observation, guys. So how I am selecting this particular clustering and how I am able to perform the logic of this clustering. Okay, so specify the desired number of the clusters. How many clusters you want? Maybe 3, 4, 5 according to the requirement. And randomly assign each data point to the nearest cluster center. Here it is calculating the mean value, and the mean value surrounded. Okay, whatever the values, just we are making as a form of the group or cluster. That is what the reason we are knowing the k-means clustering. Okay, so observe here, randomly assign each data point to the nearest cluster center and compute cluster centroids. Just you need to compute the centroids. Reassign each data point to the closest cluster centroid. Like that, we are performing the recursive activity. That is what the reason, guys. Here, see, in the first diagram, just we are selecting the k value, and in the second diagram, just we are assigning each object randomly. Some two clusters has been assigned, but after applying the cluster means, just obviously the points are getting shuffled. Okay, why this particular shuffling happens is maybe all these kind of the points are having the common centroid values related to the mean value. Okay, that is what the reason we are having this name of k-means clustering. And then recompute cluster centroid and repeat the above step until no improvements are possible. No improvement in the sense, even after repeating 5 times or 6 times or 10th time also, the appropriate cluster points are not changing. Maybe I asked two clusters and two clusters are remaining after 10th time or 20th time also, they are not changing the data points. Then it is enough to stop the process. It is enough because that particular process is a optimizer process, and where that particular optimizer process helps us to finalize the similar points into the number of clusters. And there is a bigger problem, guys. Actually, suppose assume that we are having 1,000 data points to cluster, and how to decide whether I need to select 4 cluster, 5 cluster, or 10 cluster. So if I am selecting two less, there is a bias kind of thing. If I am selecting two more timing is required. Suppose if I am selecting 500 clusters, okay, maybe they are very less differences between among clusters also. Our aim is not that, friends. Maybe some sort of dissimilarities would be there, but there is a chance of clustering or grouping into one kind of the group is required. So the k-means clustering, just on the range of k values, plot the percentage of variance explained on y-axis and k value on x-axis. This is simple methodology, guys. Like we are computing the variance value and how this particular variance is behaving. Maybe like this. Now, if you draw a kind of the line, here it is getting drop actually. It is looks like some elbow kind of the shape. So at a certain point of time, okay, maybe I'm taking 4, 5 like that at 3.5 or something, and it is we are getting the degrading of this value. So you can stop clustering at that moment. So based on this particular thing, you can iterate the k value. Okay, we have to iterate the k value. So this particular elbow method is most commonly used technique. And if you are considering the elbow method, already though I have shown to you, but again, if you refer this particular elbow kind of the technique, where this elbow technique is very much helpful to the developers, where I can stop or how do I decide the number of clusters. So here also, guys, just at this moment, it start degrading, and so it is enough to stop here. Okay, so just because after this particular point, all these points are narrow downing, they are converging actually. So how I can decide what is a good cluster? If you remember, friends, in the regression also we have seen some best fit line. Okay, what do you mean by a best fit line is with the OLS. Okay, ordinary least squares. If your error is less compared with model versus your original data, that means y pred versus y real test or y original data. So if the appropriate values are if the appropriate errors are very less, then only I can say my model is really doing well. Here also, how can I define a good cluster is data points within the same cluster should have the same similar profile. So within the variance should be less and across variance should be high. Suppose I'm having cluster 1, uh, cluster 3 like that. So within the data points, the variance should be less. Between the clusters, the variance should be high. This is a quite a natural phenomenon. So like within the cluster, whatever the data points we're having, all those data points are similar kind of the things in nature. Whereas if you are considering the comparison of two different clusters, definitely the distance is more and similarities are very less. Then that is the reason why the points are spread over to multiple clusters. Okay, so and well proportioned, and moreover guys, there is no hard rule like that. So actually this minimum 5 and maximum 35, some kind of the researcher shows that these kind of the things can be considered for the good cluster analysis. It's not a rule, but as a baseline or as a best practice you can consider. And of course you might be having this doubt like how we are comparing the k-means and as well as the hierarchical. K-means, of course, we have seen some centroids, and every time we are generating some kind of the cluster, and the terminating condition also, whenever there is no change in the number of clusters and the points within the cluster, you can stop. But in the hierarchical clustering, entire points are reached to a particular cluster until we have to repeat. So k-means clustering works on large data set, whereas hierarchical clustering, there is a limitation, guys. With a small data set only, we need to for the small data set, we have to consider the hierarchical. But k-means clustering is good for heavy data also. In hierarchical clustering, number of clusters decided after the model building, whereas in k-means clustering, we need to decide the k before building the model. This is one of the important point, friends, because the elbow method is the most famous method because we are giving control to the developer. Okay, in the hierarchy cluster, you need not specify the number of clusters, but in the k-means clustering, the developer can suggest the number of clusters. And results are reproducible in hierarchical and not for k-means, because hierarchical, there is a certain hierarchical kind of thing. So obviously the reproduction of the results can be possible. Now, whatever the points we are talking, guys, because I have started the cluster and we are having some customer data with us, guys. Just this particular customer data is giving us some sort of the information, and let us try to understand what exactly our observation in the discussion of the clustering. Okay. So just now what I'm doing here is, guys, just I'm using the um, all the Python based packages, NumPy, Pandas and Matplotlib. So just we are performing some reading operation of the mall customers data. And 1 minute, guys, let me open that customers data so that you can see market basket analysis, all customers data. 1 minute, guys. Mm. I stored in our folder actually. Just a minute, guys. Okay. So within this particular thing, let me try to give you this particular data is containing some information related to their purchase rates and as well as all these earnings, because already we have seen in the earlier example of while discussing about the unsupervised learning, maybe there are two classes like how much they are earning and how much they are spending. Okay, these two are the things we have considered. Now what we are doing is just we are trying to get what is the relationship between those kind of the earnings and as well as the spendings. The persons who are earning more, there is a possibility of spending less. More spending, more earnings, and more spending and less earnings. And there are certain possibilities, friends, where some 4 or 5 combinations would be there. The persons who spends more may be earning very less. Our target should not be this category, guys. As Tesco example, I have said. Okay, though we are getting more profit, if they are if their products are harming to the customers, maybe 60 years greater or 70 years greater, they should not take the more sugar or more calorie food. Okay, so that we can suggest for something like multigrain or whatever, millets based, because those though we are losing some sort of the business, but still we are focusing on the health of the customers. Okay, so let us try to understand, guys, here from sklearn, and from this particular cluster, just we are importing the k-means. Okay, and now what we are doing is with respect to the k-means kind of thing, there is a method like number of clusters. Okay, just here I'm taking 1 to 11. So first I need to find out the elbow method, then I can apply the number of clusters because I don't know how many clusters I need to prefer. So for that particular purpose, friends, a simple analogy is just let me generate this particular data in such a way that just I'm using the k-means algorithm, and this is the model fitting, and then we are appending every time whatever the data items we are having. So k means inertia. So just it is plotting. It is a typical programming construct. So 1 to 11, all the data items. So I can take 1 to 10 data points as x-axis and your title and y label. Okay, so just it is a kind of distance measure. Okay, sum of squares. Okay, with respect to the cluster. So sum of squares we are computing. Now the appropriate values at a certain point in time, just you see here, it is getting down actually. So up to this particular point I can take, friends. So that from this particular diagram I can see that between 4 and 6 this elbow occurred. So it is enough to consider the number of clusters as 5. So there are certain methodologies. So this is one of the best method where the programmer or developer can use so as to decide the number of clusters. Now, if you refer from this particular elbow method, we realized that after 5, if I am giving 6, 10 or something like also, it is not giving any differentiation. So it is enough to consider this fifth, whatever the point I am having number of clusters. So just I am making use of this k-means number of clusters. I am giving 5 and I am using the k-means algorithm. So just I am fitting this. And I may not sure what exactly these points are talking. Maybe you can sense like this, guys. All these zeros are forming one cluster. All these fours are forming another cluster. 0, 1, 2, 3, 4. Total 5 clusters now. As I mentioned, 5 clusters. And you are having 0 first cluster. 1 is second cluster. Third, of course, third cluster. 4 and 5. Okay. So 0, 1, 0, 1, 2, 3, 4. Okay, 5 clusters, all these particular 5 clusters. And this is again a typical programming construct so as to generate the image, guys. And you can stop here. But if you are stopping also, but how to convince or how to get the insight of this? And as a developer, you can say that all these zeros are first cluster, all these ones are second cluster, all these twos are third cluster, like that you can say. But to the functional users, that is what the importance of the visualizations. Okay, you can narrate a story up to this particular thing, guys. But with the proper visualization, okay, you can guide that. Okay, these are all 5 clusters. And coming to the cluster 4, this yellow colored, where the annual income is very less and they are also spending less. That is a cluster 4. And coming to the cluster 5, this thing actually, this is spread over. The annual income is ranging from $80,000 to $140,000, but still they are in the range of low spendings only. Okay, they are in the low spendings only. Coming to the cluster 3, this one, guys, actually their earning is also $80,000 to $140,000, and of course they spending also more. Whereas if you consider cluster 2, this green one, their spending is very low, but their earning is low, but they are spending more, guys. Who should not target these customers? Already they are spending more, whereas their annual income is though less, but they are spending more. And coming to the cluster 1, these guys, their average 40 to $60, and of course $40,000 to $60,000, and average spending. Now, obviously, guys, if you refer, uh, these guys are the target audience, guys. Your cluster 5 is target audience. Your cluster 5. Okay. And moreover, these are all okay. Less spending and less earning. And you should not target this cluster 2. Already they are spending more, though they are getting less. Of course, we don't know whether they are paying tax or whether they are hiding. That is a different story, guys. We are not going into that. but only as per the data, just we can sense this kind of the analogy. So this is how you can see, simple guys. This is not a big programming construct and all, and definitely you need, of course, definitely you need some sort of the visualization techniques and all those kind of the conventions. Okay, so with little practice, you standardize the things, friends. What I'm saying here is maybe in your day-to-day life, you need to load the data and you need to pre-process the data. And moreover, in your project, 70 to 80 percentage of your time is dedicated to your data pre-processing and as well as the model fine-tuning, because initially whatever the results we are getting, that result may not be satisfied. Okay, it is not satisfactory. So in that particular case, definitely you have to again reinitiate the appropriate aspect and finalize the things. So this is how you can observe the orientation of clustering mechanism. Okay, and similarly you can go through the hierarchical, because hierarchical is not that much catchy, because k-means clustering is a reality, and of course with the some sort of similarity measures and means, centroid calculation, sum of squares, and elbow method. Okay, where we are having all these kind of the conventions. Okay, all the evidential aspects, why I need to choose number of clusters as 5. So the your elbow method implementation just with the help of this usage of the k-means algorithm. So this is how you can follow up with your approach of k-means algorithm. Okay, now, so apart from those kind of the conventions, we are having one of the important thing. Every data scientist should know about this particular thing, guys, because most commonly just the members are trying to use this thing, and as a kind of generalization, every data scientist should be aware of this market basket analysis. So let me give you the approach of this particular market basket analysis, so that you can after that we can start with our presentations. Let me give you that convention. What do you mean by market basket analysis, MBA? So just if you are referencing the market analysis. So friends, if you observe any supermarket example or any book purchase example, suppose if I am purchasing Hadoop by Tom White, maybe my Amazon suggest me you can take this Spark the Definite Guide also by Meti Jaharia. So that means it is having some kind of the association or dependency. Maybe like this guy. Suppose if I am purchasing one product, definitely product 2 is also purchased. Suppose if some member purchasing product 3, product 5 also purchased in many 99% of the cases. So what I can do is, suppose if a person purchasing P3, I can recommend P5 also. And I can expect if a person purchasing P1, maybe P2 can be recommended as 99% of the cases. Okay, P1, after purchasing P1, definitely the people purchasing P2 also. So that kind of aspect is coming under the category of the market basket. So what is the advantage is, guys, here to understand the pulse of the customers and to suggest the appropriate products, because customers time is most valuable, and at the same time we can also improve our business strategies, like by placing the appropriate products. Maybe in the supermarkets if you are going, so just they keep all these coriander and all these curry leaves at one place. Okay, so all these leafy vegetables they place in a separate rack so that you can collect all those things. And if you are going to another rack, they never place vegetables and as well as fruits in the same rack. So all the fruits they dedicatedly maintain some kind of the rack, and within that you can see all these grapes, banana, all these kind of things. Whereas in some other rack, all the milk products. Okay, so curd, milk, and all these kind of cherries, like that you will be seeing. So the point here is there is a segregation, guys. There is a segregation. Then obviously the products, okay, whichever interested for the corresponding customer, and he can easily pick up and quite handy, and he need not every time call the executives or supporters of that particular mall. And as a, such a bigger mall, every time okay, it's not feasible also. And sometimes in the rush time and all peak hours, just we are going to get some one or two products. But for that particular case, we are having only 10 to 15 minutes of the time. That mall is very near to our residence. So just we'll go and pick that particular thing. So to maintain all these conventions, not only the benefit, not only for the business, for the sake of fastness, because time is more important now, so that we are making use of that thing. And let us understand what is the analogy behind the market basket analysis. Okay, observe here, guys. Market basket analysis is one of the key techniques used by large retailers to uncover association between items. So as I said, many items, maybe Walmart or Tesco or whichever, and maybe if I'm talking about the e-commerce websites, Amazon, Flipkart, all these kind of things, it may not always the physical entries, guys. Maybe some books, if I'm electing one book, if I'm choosing one book, so automatically it refers, because maybe the similar content or similar kind of the author might be there, or else the customers themselves, they would have purchased the second book along with the first book. There are two factors, guys. One is similarities among the books. Second is the profiling of the users. Okay, maybe I'm belonging to 30 to 40 group. So just if you are referencing that thing, maybe the people who are having 40 to 50, their suggestions may be different, and 50 to 60, the members are distinct. So now the point is based on the profiling, first they will be segregating, and because as Amazon or Flipkart, or they are knowing about us, okay, so this they are suggesting some of the products based on the profile ranges. Okay, now it works by looking the combination of items that occur together frequently in transactions. Frequent item set, a priori algorithm, like that we are having some sort of the algorithms, guys. Only these particular algorithms helps us so as to find out which are all the items occurred most frequently. Because guys, at least two items, that is a two item set, and three items together, if I want to perform three item set, like that we're having some sort of mechanism between them. So two item, three item, four item set likewise. Okay, and now it allows retailers to identify the relationship between the items that people buy. It is also known as affinity analysis or association rule mining. As I said earlier, it may not always be a market basket analysis, and I can say that as association rule mining also, because these association is nothing but some sort of the combination. So if any particular member purchase one product, and is there any other product they are purchasing. Now, if you are observing the understanding of the association rules, the result of the market basket analysis is set of association rules that specify the patterns of the relationship among the items. Maybe peanut, butter, and jelly, and they are purchasing along with the bread. Okay. Likewise, whatever the dependency, actually this is a three item set. These three items are purchased along with this particular bread. Okay. So obviously, if you purchase any butter, and we can recommend some kind of the peanut or else jelly or bread, whatever the kind of the convention. Now applications already understood, guys. Maybe in terms of e-commerce or any retail kind of the supermarkets, all these kind of the things are giving us some sort of association rule. And one more thing is here, this application related to the fraud detection, finding patterns of purchase or medical claims that occur in combination with fraudulent credit card or insurance usage. Nowadays, guys, claiming of this insurance, they are doing some fraud actually. So just wrongly they are claiming, and they are claiming some kind of the grants. So as to observe these fraudulent credit card or insurance based kind of the transactions, we can make use of this market basket analysis. and finding dangerous interactions among medications. This is one more the medical diagnosis kind of the process, guys. Because after using certain medicine, the suppose if there is any other medicine if I'm using on that particular DNA or on that particular blood group, you may get some kind of the side effects. So the doctor should be very cautious. Maybe for the O positive members, these two medicines should not use together. Maybe I can use one, and next day or after 2 hours or 3 hours, based on the reactions, I can supplement that usage. So this is also one of the important thing, guys. Like it is always not the positive thing. Like after purchasing bread, peanut butter and jelly, not like that. Suppose one medicine after applicability, if any side effect is there for this O positive kind of the blood group people, I should stop using those kind of the conventions. Okay, and movie recommendations, of course, while seeing this Amazon Prime or Netflix or whichever, guys, automatically after selection of such a movie, just it will give you some recommendations, maybe based on the same director or same hero. That is one thing. Product based, one is a product based, second is user profile based. Like maybe similar users, they are opting for the other movies along with this selected movie. So in these two kind of things, user profiling and product based, okay, in these two ways the recommendations can be done. And identifying combinations of behavior. So suppose if I want to observe some kind of the combinations and how I can make use of this convention, based on that aspect also you can make use of this association rule mining or market basket analysis. Now the advantages, friends, generally useful for data mining and discover unexpected knowledge in databases. Definitely, by just seeing the data, we cannot get the insights. And results in rules are easy to understand. Definitely, guys, because some rule generation is possible. You need not generate any rule. Association rule mining or market basket analysis generate the rules. The same rules can be applicable or observed for the other data sets, and is ideally used for working with very large amounts of the transactional data. Generally, guys, like suppose if I'm having the transactional data, then only I can identify, okay, these are all the transactions done by the user, and these are all the products involving, and these are all the byproducts as a part, like that I can say. But the pitfalls are also there, guys. Pitfalls are also there and not useful for smaller data sets. Suppose if I'm having very limited kind of the data, definitely if your market basket analysis or association rule mining may not be we cannot expect that much great results with smaller data set. Always your association rule mining quite handy with the larger data sets. Okay, and the another problem is takes effort to separate the insight from the common sense. This is the biggest problem, guys. All data scientists, not only with the market basket analysis or association rule mining, but friends, the another point is how do we capture that particular data and how do we story tell with that particular data, because that is one of the important things. So our data scientists, data engineers or machine learning developers does everything, but only the thing is majority of the feedbacks or majority of the critics revolving around this storytelling only. Though they are very proficient in the coding, and though they can explain all the corners of the algorithms, but they're unable to connect the loosely connected loose ends. They are unable to connect, because after the discussion, after the floating of this metrics, but how do I interpret the data, especially in terms of the clustering and especially in terms of the market basket analysis? Because in terms of classification and regression, at least we are having that metrics, we are having that kind of the measures. There is a number, and based on that number you can play. But in clustering there is no such kind of the things, guys. In the example also we have seen it is given a kind of the number of clusters, and again we need to visualize that particular thing. Okay, with the visualization only we have to run the show. Like the concept of visualization helps you to explain the things, And your common sense reasoning is also most important, friends, in terms of explaining all these kind of the considerations. Okay, so now the appropriate principle, if I'm talking, obviously the association rule mining, whatever the items I'm having. So just we are making use of some sort of the algorithms, and based on that particular algorithm, we can perform some sort of activities. And most importantly, guys, we are having certain measures. So definitely I have to talk about those kind of the measures, support, and as well as confidence and lift. And this is on top of your data. So just we need to come up with some kind of the analogy. Let me put that particular aspect. So let us try to understand this example, guys. Okay, have a look on this. We are having this, as I said, we should have the transaction data. Um, and now we are having this set of the data, friends. Okay, flowers, get well soon card, soda, and these are all most frequently bought. Okay, so like all these kind of things. Some members would have. This is a 3 item set. This is a 4 item set. Again, this is a 3 item set with another combination, and this is also 3 item set. 3 item set. What is the 3 item, 2 item? Suppose product one, product two together appeared. This is a 2 item. Product one, product two, product three. This is a 3 item set. Like that, how many number of items are there in that particular combination? All those things are nothing but the item sets. Now, there are certain measures, as I said, support, confidence, and lift. Okay, the third measure is the lift. What do you mean by support actually? Majority of the developers use this support and confidence, guys. Now, the support of an item set rule measures how frequently it occurs in the data. How frequently it occurs in the data. Maybe flowers. Almost all you see, guys. Flowers, except in this particular fourth, almost all 90% of the data is containing flowers. Okay, count of that by number of items. So where n is the number of transactions, maybe 5 transactions. Out of that 5, how many times that particular flowers occurred? 4 times. This is the support, guys, actually. Now, for example, now if you are considering count, indicate that the number of transactions the item set X appears in how many number of transactions that X appears. Suppose I want to find out how many times this get well card and flower occurred together, guys, together. So get well card and flower one time. Here it is not appeared. Here it is appeared second time, third time. Okay, so 3 times it has occurred together. Get well soon card and flower 3 times occurred. And what is the total number of flowers? Total number of occurrence of the flowers actually. So if you are seeing that number of transactions, 1, 2, 3, 4, 5 clearly. So 60% is your support. Similarly, support of candy bar. Candy bar, just let me see one time, two, here no, here no. Only 2 times it occurred, guys. Okay, 2 by 5, only 40% I'm having the support. Whereas flowers, as I said earlier, 1, 2, 3, 4. 4 by 5. 80% of transactions are containing flowers. And get well soon caught. One time, second time, third time. So 3 by 5. 60%. So likewise, your support is saying how many number of transactions are there related to that particular product. Maybe 1 item set, 2 item set, 3 item set, whichever. Okay, in all these sort of the data items. Now let us understand what do you mean by a confidence. A rule's confidence is measurement of its predictive or accuracy. How accurate? How to define that? It is defined as the support. Already support we have seen number of transactions by occurrence of that particular item. Okay, it is defined as the support of the item set containing both X and Y divided by support of the item set containing only X. What I can say here is support of Y along with X comma Y. That is what you call the confidence. Now, suppose how I can say is how many times y occurred after occurrence of the x. That means I purchased x and I also purchased y. That means after getting this x value, how many times I got this y value. This really gives good, no? Because occurrence of a particular item in number of transactions is one thing, that is higher demand is there for the product. But the reality here is, guys, we need confidence also. Confidence means suppose I'm getting the x value and how many times it is yielding y also. So the support of x comma y by support of x. Again, that confidence can be computed in the combination of the support only, guys. Okay, support of xy, already we know that how to compute that. Okay, so confidence of flowers get well soon. 75% of the confidence is there. So flowers, whenever I'm taking, and it is associated with the get well card also. And confidence of if I am taking the get well card, those many times flowers, and it is a not reciprocal relationship, guys. Suppose flowers if I am taking, and how many times I have taken the get well soon card. Maybe friends, always these flowers may not be for the bedridden guy or the member who is admitted to the hospital. Maybe for some other purpose also. Maybe he got promotion, or maybe he's after world tour he came back to India. Maybe something like that. So in that case, always flowers may not be coined by get well soon, because until he is in hospital and we want to wish him, then only we can take this. But get well card, okay, always accompanied by flowers, guys. Flowers may not return the get well soon card always, but get well soon card if I'm taking, definitely I'm taking the flowers also. This is the confidence actually. Okay, so get well soon card if I'm taking, flowers obviously I'm taking, but along with flowers, only 75% of the cases I'm taking the get well caught. Okay, so the confidence tells us that the proportion of the transactions where the presence of item or item set X results in the presence of item or item set Y. In that item set Y, whether that presence is there or not, that is what you call the confidence. And this is also one of the interesting measure, guys, like the lift. It is a measure of how much more likely one item is to be purchased relative to its typical purchase rate. So given that another item has been purchased, suppose already one item purchased, and how equal the next item also purchased. So for that particular thing, and one of the important thing, guys, your support is a basis computing, and your confidence depends on the support. And if you are scoping the lift, and lift is combination of the confidence and support, guys, so that it is talking about the dependency of x and y, and it is also giving the support value. So obviously, guys, don't expect 90% or 80% kind of thing. It is a value actually. So the more lift ratio is better it is. We have to consider rules where the lift ratio is greater than 1. Okay, and the rules which are all having greater than 1 value, then only we can consider. So if you observe the get well card, appearance of the flowers. Okay, so this is how you can specify the understanding of the lift value. So this is what how you are making use of the convention related to the support, confidence, and as well as the lift. Okay, so and one more thing, guys, I want to talk, but let me give you as a task kind of thing, which is most important. Dimensionality reduction, most important topic, guys, because already we have seen some missing value imputation, encoding techniques, all these things. But along with that, you can study the dimensionality reduction, and as well as the other point actually. Along with the dimensionality reduction, we are having such as this standardization and normalization. Okay, so those things you can see. And just I'm stopping here, guys. So just let me ask our members. So to start the things, Harshita and Pawan.
Yes, sir.
Yeah, please. Yeah, first you can start and let me ask how many members are there. Ravi Kumar, best practices in Spark. Ravi Kumar, are you there? Okay. So Richa, PySpark window functions. Okay, not there. Subramanian, explode, concat, array contains. Yeah, Subramanian there. Okay. Sanja, random forest and its importance. Okay. Bharadwaj.
Yes, sir, there.
Okay, so out of these things, Subramanian is there, Bharadwaj is there. Okay. Ansari, decision tree usage and importance. I have seen Ansari.
Yeah, I'm
Yeah,
good.
good. Yeah, okay. And Shashikant must be there.
Yes, sir.
Methods
Sir,
of
here.
regression.